Today I'm going to present about intelligent text mining for ontological knowledge graph, refinement, and patent portfolio analysis. Case study of net zero data centers innovation management. Contents are followed. An ontological knowledge graph is a knowledge representation approach that formally structures and visualizes entities, attributes, and the relationships among them. The semantic process of collecting, integrating, and representing knowledge with a specific domain is defined as ontology engineering. The constructions of OKG contributes to innovative knowledge management by providing a coherent research framework. A data center is a core facility of modern ICT infrastructure composed of large-scale servers, network equipment, and storage devices. In response, the European Union issues the Energy Efficiency Directive in 2023, mandating annual reporting of data center energy performance starting in 2024. This study begins with a comprehensive literature review of DC net zero technologies, the systematic constructions of an OKG. This study aims to construct an ontological knowledge graph-based analytical framework to systemically analyze net zero technologies in data center using patent data. This study established an OKG-driven research framework that clearly defines the knowledge scopes of data center net zero technologies. It integrates patent trend analysis and NLP techniques to enhance and refine domain OKG. The study applies the refined OKG to technology maturity assessments and hotspot-cold spot identification. Ontology is defined as a description that standardizes abstract, ambiguous, and domain-specific concepts and transforms them into structured knowledge systems. An OKG is a visual knowledge representation that structurally depicts entities, attributes, and their relationships. OKG are widely used as core analytical tools in innovation knowledge and technology management research. In prior studies, a common approach is to first construct an OKG through a comprehensive literature review and a reference framework for patent retrieval and analysis. Existing OKG-based studies exhibit a limitation in the systemic updating and refinements after the initial constructions of the OKG are insufficient. This limitation leads to technological progress and changes in knowledge structures are not adequately reflected in the OKG. Recent studies have increasingly focused on automatic generations and expansions of OKG using machine learning and NLP-based text mining techniques. Keyword extraction is a core technique for identifying important concepts and themes from large-scale text-based documents. Keyword extraction methods can be broadly classified into three categories: simple statistical method, linguistic method, and machine learning method. Simple statistical methods focus on word frequency, word positions, and inverse document frequency. Linguistic method relies on grammatical and semantic analysis. In recent patent mining research, keyword has emerged as a popular keyword extraction method. Keyword is an unsupervised keyword extraction approach that leverages semantic similarity between document embedding and candidate keywords. This characteristic enables keywords to extract semantically meaningful keywords. Also, typically asserts as employed keyword in combinations with normalized term frequency to analyze publication trends related to the United Nations Sustainable Development Goals. Clustering aims to portion a dataset into multiple subsets by maximizing similarity within the same cluster and minimizing similarity between different clusters. Clustering methods can be broadly classified into hard clustering and soft clustering. Hard clustering assigns each data point to only one cluster. On the other hand, soft clustering allows a single data point to belong to multiple clusters. K-means is a widely used unsupervised clustering algorithm. This algorithm required predefining the number of clusters and aims to maximize intra-cluster similarity while minimizing inter-cluster differences. Trappey extracted key terms from RFQ documents using n-gram TF-IDF and subsequently applied k-means to cluster sentences associated with each specification. Topic modeling is used to identify latent topic structures embedded in large-scale text data. The primary objective of topic modeling is to automatically uncover hidden thematic patterns and semantic structures. Topic modeling approaches can be broadly categorized into probabilistic generative models and information theoretic models. This study introduced topic modeling method with a focus on two representative models, LDA and CoreX. LDA is a probabilistic generative topic model that assumes documents are mixtures of multiple latent topics. In prior studies, patent data related to CPAs and solar energy technologies were collected, and LDA-based topic modeling was employed for in-depth patent portfolio analysis. CoreX is an unsupervised information theoretical model that learns latent vectors with high information contents and low redundancy by capturing correlations among variables. Technology maturity analysis is a method used to identify the developmental stages of technologies and products over time. The concept of technology maturity originated from the product lifecycle theory, which consists of four stages: introductions, growth, maturity, and decline. Technology maturity analysis has been widely applied in patent-based studies across various technological domains. In this approach, patent data from a specific technological field are statistically compiled to calculate the cumulative number of patent applications or publications. The S-curve is grounded in the logistic growth model and is used to assess the current maturity stage of technology. This model enables a quantitative interpretation of technology growth speed, saturation level, and inflection points. This study constructs an ontological knowledge graph based on literature related to DC net-zero technologies. Using the design search strategy, a domain-specific patent dataset is established, followed by patent trend analysis focusing on publication trends, major assigns, and CPC code. Subsequently, the OKG is enhanced through keyword restrictions using k-means and keywords, and topic modeling based on CoreX. Finally, technology function metrics analysis and S-curve analysis are applied to evaluate the functional distributions and maturity of the technology. Existing studies mainly address green data centers and efficiency-oriented technologies which cooling, resource management, thermal control, and sustainability indicators. This study constructs on OKG to systematically organize DC net zero technologies. The OKG conceptualized the DC as a core objects and defines sub-technologies from a net zero perspective. The scope covers technologies aimed at minimizing carbon emissions across DC constructions and operation. Sub-technologies are decomposed into functional units and linked to patent analysis. Cooling optimizations is essential for improving DC energy efficiency. Resource management focuses on efficient power and water utilizations. Thermal management technologies aim to reduce heat-related energy waste. Carbon management systems monitor, assess, and reduce DC emissions. High-efficiency IT integrations reduce energy consumptions under equivalent workloads. Network and storage optimizations further enhance DC energy efficiency. This study designed a patent retrieval strategy to conduct a patent analysis focusing on DC net-zero technologies. The search query is constructed based on three core keywords components, which are combined to use Boolean and operator AND. With each component, the Boolean operator OR is applied to comprehensively cover diverse technological expressions. Specifically, patents are limited to those with at least 3 patent families and applications year ranging from 2014 to 2023. A manual screening process is subsequently conducted to remove patents that fall outside the scope of the study. During the process, titles, abstracts, and claims are carefully reviewed to exclude irrelevant patents. This analysis aims to interpret patents data from a macro level and holistic perspective. Rather than focusing on individual patents or fine-grained technical details, the analysis emphasizes overall trends, relational structures, and aggregate performance. Through this approach, decision-makers can gain a comprehensive understanding of the technological landscape. The patents data are examined through a systemic process involving data cleaning, organization, visualizations, and interpretation. The main analytical dimensions include annual patents publication trends, major patent assigns, and CPC classification structures. These dimensions enable the identification of technological development trajectory, key innovations actors, and areas of technological concentration. Patent abstracts were analyzed after applying text preprocessing. The preprocessed texts were transformed into numerical feature space using TF-I data factorization. The k-means clustering algorithm was applied after determining the optimal number of clustering using the elbow method. Keyword-based keyword restrictions was conducted for each cluster. Core as topping modeling was employed to extract latent topics and core keywords from the patent text. For each topic, keywords and their corresponding weights were generated to quantitatively characterize the topic structure. The core as topic results were mapped to the k-means clustering outcomes. Finally, the analysis results were cross-validated with the initial construct of KG. This study systematically analyzes patent distribution and technological hotspots across technology functions combinations by employing a keyword-based ETFM. Technology function datasets are constructed separately and keywords are extracted using keywords. A relevance score between patents and technology functions is calculated based on the ratio of overlapping keyword scores. A binary matrix is generated by applying a predefined threshold. The final technology function matrix is derived by multiplying the technology binary matrix and the function binary matrix. Technology maturity analysis is conducted by applying an S-curve model based on the annual cumulative number of patents for each patent cluster. The key parameters of the logistic growth model is saturation level, growth level, and inflection point. Model fitness is evaluated using the residual sum of squares as the loss functions. Gradient descent is applied to indirectly update the parameters and minimize the RSS. Ultimately, the current maturity stage and future development trajectory of each technology clusters are predicted. The patents trends reflects growing global attention to energy efficiency and carbon reduction. These firms plays key roles in ICT infrastructures, low carbon data centers operation, and sustainable data center solutions. The specific number of the statistical is you can see at figure 3. Text analysis was conducted using the titles and abstracts of the retrieved patents as input data. Based on album method, the K is derived as 5, and keyboard-based keyword restrictions was applied to each cluster to interpret their underlying technological themes, as shown in Table 1. Due to the conceptual overlap between cooling and heat management technologies, the original clusters 3 and 4 are merged. Core X-based topic modeling was conducted, yielding a total of 10 latent topics across the patent corpus. Each topic was characterized by semantic descriptions and representative keywords. This reflects the interconnected and convergent nature of these natural technologies. At figure 4, the clustering and topping model results are shown. The initial OKG was found to effectively explain and organize most of the core technology domains. However, networking and communication technologies were not sufficiently represented in the initial OKG. This is because the initial OKG focused on DC operations, maintenance, and direct carbon reduction. Based on the analysis results, subdomain T3, T4, T7, and T8 were newly incorporated in the OKG. The subdomains include virtualization, cloud service, networking, and optical communication technologies. They play a critical role in implementing DC net zero technologies under a server as a service paradigm. The enhanced OKG address technological gaps and provide more comprehensive coverage of DC net zero technologies. Technologies and functions were defined based on refined OKG. Keyword matching based on keywords were applied to transform technology functions relationships into a binary matrix for analysis. T1 recorded the highest cumulative score, and F1 achieved the highest cumulative score on the functional dimension. Based on K-means clustering result, technology maturity of each cluster was evaluated by modeling cumulative patent counts using an S-curve. Cooling and heat recovery technologies are observed to be approaching the late growth stage. C1, C2, and C4 are assessed to have strong mid to long-term growth potential, driven by data center infrastructure expansions and the diffusion of server-as-service models. The practical implications of this paper is first, OKG-based patent analysis framework provides a systemically methodology for understanding technological structures. Second, by integrating NLP-based OKG refinement, ETFM, and S-curve analysis, this study demonstrates that technological hotspots and maturity stage can be objectively identified. Lastly, the proposed framework is not limited to the DC domain and can be extended as a generalized patent analysis methodologies applicable to other technological fields. However, there is a limitations that the literature and patent data are confined to specific database, and the SCAR-based technology maturity analysis relies on historical patent data, making it difficult to fully capture disruptive innovations. Lastly, subjective judgments may be partially involved in the initial constructions of the OKG. Thank you for listening my presentation.